now we continue our class. So this is the part design, where we have given a name housing for the part, and this is geometrical set. This is a part drawing. What we do is we select this part body and click on define the work object. Okay, you just follow what I say. Earlier it was this work object. We do not do that, and click on this and select this as the work object. We have on the screen here few toolbars. See, there are so many toolbars here. Some of them active, some of them not active. See these, and also the screen appears to be something like a blue color. And suppose we want to change the color of the screen, and we do not have any grids, and we want to add grids to the screen, and we do not have any axis. Suppose we want to add an axis to the screen, etc. Then what we have to do is we have to select an option. It is under screen an option, and click on option. Just we do it in AutoCAD. It presents a option screen here. It has many branches: general, display, compatibility, parameters, measures, devices, infrastructure, machine design, shape, analysis, etc. So many things are there. And here is sub-menus are also there. Here what we are going to do is we select the properties of the screen. That is how our object should look on the screen, and what should be its color, and how the sketcher screen where we draw the 2D drawings, how it should be. It should have a grid or not a grid, and what is the units we have to use in the drawing. All those things can be selected here. Here in the general, we'll analyze one by one. This is general. Here it was P1, P2, P3. We have selected P1 now. We can select P2 also. Restart Catia with modification into account. So we will select only P1 at present. Okay. Help. Any help is there. Help files are not available here. There is nothing we can do now. And shareable products. Here list of products granted using license. These things will appear here. And licensing, it gives you a few other things. We are not to worry about it. And documents. Here it shows folders, states, catalogs, etc. Don't worry about these things now. And CAD script, internal V5 editor, IMS V5 editor. Don't worry about this now. Comes to performance. Start stack size. So leave it as it is. Don't worry much about it. At present, printer, it selects the printers. At present, on the screen, on this PC, there is no printer. Don't worry about it. Server manager, limit the user one per person. This you can click. You can use only one person, this Catia here. And then it shows statistics, buffer size, file menu, etc. Activated workbench is activated. That's what we call this is the called workbench that is activated. Activated comments and statistics activated. Server statistics, session statistics, all those things are activated. Now we come to display. Here, the display of the screen. See tree appearance, classic Windows style. This is called the arrow mark. This is called on the same screen. The descriptions are there. Part, body, plane, etc. These descriptions are called classic style. Constructive historic. It is a different type. We will not discuss, but it will be a separate screen. On structure, it will be different. Relational, it will be different. So we will select only this at present. Okay. And now, tree manipulation. Automatic scroll activation during draft, drag, drop. Display geometry during the tree scrolling. This display geometry during this one. Automatic expand activation. these things. Rezoom after clicking. You don't worry about it. You will know about it gradually once you start working. And now at present I am not dealing this. And navigation, this is also we don't deal. Performance, don't worry about it. And visual, here we can, some of the things we can select. Graduated color background, graduated color background. We'll explain what. I will just select and explain. See, I have selected this. Now see appearance here. I will click and see how it appears. See, this is graduated. See, okay, I will show you once again. This is graduated color background. Background is this. This is the background. The arrow mark is the background. This is graduated. This gradually at the top it is dark and gradually it becomes light gray at the bottom. You don't select it. It is fully same color throughout. And also here we can change the color. Suppose I want to change the color to black. Click here, screen has become black. And on this screen also you can select graduated. See here, click graduated. Okay, so I will have the present screen as it is. I will leave it. This is the screen we are selecting. We are not graduating. And similarly, you can select any color. If you want to select this color, you can this color. So this is how we can select the colors. So I will have this color left. And then screen elements. See, I will just click it. What we can see here. Screen elements. See, lines will be white or any color it can be. I will show you later on how it looks. Suppose you draw a picture, a 3D, it adjust will be white now. If you don't want, you can make the adjust black. Okay, so adjust will be black or whatever you select, it will be there. You can select this brown color. Okay. Selected the edges. It will be when you are moving, it will be of this color. And present elements, each color. Pre-selected line type. Line type you can select one. Selected line type. Low intensity elements. So these are all different things which you will know later on as you handle. This is the handle, this color. If you change the color to handle, it will be white. So these are all the things which you know after doing some drawing. Surface boundary. This is surface boundary. You can click here and surface boundary you can make it like this. Density of the element to buffer width. You just stereo enable off, you make it. There is no stereo here. And just lines, offset. So don't worry about it, you forget about it for time being. You learn about these things gradually. Okay, now we have we have selected here. Where is this visualization? Line filter, current line filter on all document, let it be. Thickness and font, you can select thickness this. You line true type fonts. You can use system type true Catia font or some other font which will be shown later on. You can use this. Line type. What type of line you want, you have this line. It's already there. You don't change anything as it is, let it be. Similarly, compactability. So I'm explaining you various options now, and some of them you will understand, some of them you do not understand now. And course of time, you yourself will understand when you start making drawings. Before data reading, 3D display elements, labels, display only elements with sensitive attributes, open the light mode 2D, leave as it is now, save data as data, V4 data, you can save as it is V4 data or anything, associativity mode, not associativity mode, no solid creation, you select all those things. Okay, file name, capital letters. It's a file name. If you want having capital, you can click on this. All file name will be in capital. That is when you save as, then the file name will be capital. And V5 create centers and end parts. Centers and end parts, let it be, because when you create a drawing, the center is required, let it be. Convert dimension into graphic, let it be there. Explore ditto when migrating to these things, you don't worry about it. Migrate blink element, you leave it as it is. V4 space, more relative value, user defined value, you just click this, that is sufficient. And then as a part body, keep 2D text not required, and use step by step updated and read it. So let it be there. Square usual mode, come in native V mode, we can select. We'll see what they think is going to happen. Catia geometric set, V4 partition, format, result Catia, convert space to and draw. And that's what all these things will leave as it is. Okay, now next I will show you each one of them step by step. Now we have done this we're done with this. Parameters. Here parameters with value, parameter with formula, let it be there. Because I will tell you what is this later on. There will be, it is a special type of 3D modeling where you can use formulas to create different lines and their relation. Suppose you have length L of a line and you have another line is related to this, and it will always have 2 times the length of this line. Say width, we'll say width of a rectangle, we will have 2 times the half times the length of the rectangle. Then we can use formula here. Once we change the length of the line, or if you use this formula, the width will be changed to half the length automatically. And the values, everything will be given, surrounded by a symbol, parameter names will be surrounded by a symbol. The creation of symbol and automatic synchronization at all nodes, it synchronizes default design table. We'll come to it later on. Now, this is an important thing. Units. We have to select the units. We have selected the length unit, millimeter. So here you can have different things, meter, centimeter, etc. Accordingly, the drawing will indicate. Now, if you select meter, whatever you draw, it will be in meters. Okay. If you select some inches, whatever you draw in inches. So we are selecting standard is meters, and we will select meter. Foot. So many things are there. We select millimeter. Angle. It is in degree. Whatever you put, it will be in degrees, radians, gradients, minutes, seconds. So we'll have degrees. Term, milliradians you can have. So we'll have this only. Okay. Time, this is only one unit. Time in seconds. Milliseconds also there. Hours is there. Day is there. Year is there. So let it be. Mass. Kilograms. Let it be in kilograms. Grams will be very small value. So we'll have kilograms, ton, milligrams, etc. So these units you can select as you need. Cubic volume. Volume you can express in cubic meter, cubic millimeter, cubic centimeter, or in liters also. You can select liters if you want. Here, click it as liters, it shows liters. So I will not select liters, I will select cubic meters. Okay, I will show you with example. Density. Density is kilograms per meter cube. This shows density kilograms per meter cube. Similarly, there are so many other things here. Area, square meter, inertia product, kilograms, square meter, that is moment of inertia. And energy, it will be in joule, represented in different units are there. Joule, newtons, force, inertia, that is moment of inertia. Kilogram per second, mass flow, moment of into Newton meter, pressure, newtons per square meter. This you can also change. Pascals you can change, pounds, kilograms per millimeter, kilogram per centimeter, whatever you want, you can change it here accordingly to be represented. Temperature, you can select degrees, Celsius, anything. So like that, various units, other power, watts you can select, or volume you can select, volt you can select, in volts or millivolts, whatever it may be. Everything you can get changed so many units. Now, language, of course, is always English only. Load extended language libraries. You don't worry about these things now. At this present, leave it as it is. Report generation, HTML or XML. Let it be HTML. Checks, let it be. Parametric tolerance. Maximum tolerance 0. Minimum 0, 0. Or default tolerance, whatever is there, let it be as it is. You don't worry, don't change it. Okay, measure. Here, automatic update in part. Automatically, it should update the drawing once you change it. Automatic update. Display approximate measurements. This is the color, here's the line width. Text color. Nice, you have selected. Symbols. These are the symbols. Resolved constraint. Constraint symbol is this. Resolved constraint, unresolved constraint, it is like this. You will know all these things later on. Over constraint will be like this. Invalid geometry will be like this. Okay. Display mode. This over, this over, symbols over. Now we come to device virtuality. Move can pass with 3D device, let it be as it is. Don't worry much about it. And table support, you don't worry about it also. Infrastructure, cache management, leave it. All these things, you don't worry. Save level, leave it. Product, part number, you can have manual input. You can give manually the part number. Then it asks you there. Part 1, it won't select. And you can put the manually. See, when you open the sketch screen, it shows part 1 and change it. Okay. Instead of that, if you click this, you can manually give the part number. So we will have some default part number. So let us not click it. Okay. Describe the model bill of material. Describe model file in the bill of material. Leave them. This you will know it later on. So you don't worry about these things. As and when we need, we can change these things. Material library, leave it as it is. Catalog editor, leave it as it is. This also leave it. Machine design. Assembly design. Automatic updating is automatic. Automatically it updates. You need not every time tell the computer by selecting a menu to update. It automatically updates. Constraint, you can impose the constraint as required. Use any geometry. Okay, you don't leave it as it is. Update propagation depth, activate level. Leave as it is. Don't worry about it much. Now, constraint, DM user action. This will not come into picture now. Sketch. How you want to look the sketcher screen? So that you can have snap point as we did in AutoCAD. This allow distortion, leave display, sketcher plane, the grids. Don't snap, let it be as it is. Primary spacing, shade the sketcher plane, need not shade it. Model tool design is not connected to this. Drafting, this will come when you do drafting operation. Then we can select these geometries, all these things. Sheet metal you can select at the time of sheet metal. Drawing, modeling, sheet metal modeling, and all this. This is the option plane where you can select. We have to deal with this more frequently as we do different types of drawings or prepare drawings in different models. Okay. Now, so I explained you briefly what is all. Now, straight away, we will start doing practical job and then we will know one by one. Now, this is called the part design screen. This is a 3D screen. See, it indicates this is a plane screen, 2D screen. This is YZ plane, this is 2D. Here we draw 2D. And XY, this is here we draw 2D. In any one of the plane we have to draw 2D drawing. That is sketching. That is called as sketching. So before preparing a model, we have to draw a 2D model, and then we use proper commands to convert it into a model. Okay. Now suppose we want to select a 2D plane. We have to click on this, and this SketchUp plane. Click on this, and you will get. So this screen size here, I will show you here. So we are ready to know. This is this. Primary spacing 100, graduation is 10. Snap to point, we are not going to snap to point. Allow distortion, we are not showing. Suppose I change it how it goes to, let us see. See. Okay. So I will go back. You can even change this to 10. See, it is get changed. Okay, this is how screens can be changed. So let it be now time being. Let us see. Now we have select. Now if you want to come back, you can click on this. You come to the model space. This you can call it as a model space, and this for our reference. And this is a 2D plane. Click on this. Come here. We are going to draw the lines. Come back. No line. So now I will draw a simple diagram. YZ plane. Click on this. Click on this. Suppose we want to draw a rectangular bar. So what we have to do? I will start from the beginning. You want to draw a rectangular bar of 100 length, 50 width, and about 1 meter length. What we have to do is we have to first draw a sketch, selecting the SketchUp plane. X, Y, Y, Z, Z. Any one of the plane we can select. So normally we select YZ plane, XZ plane also. Depending upon the convenience where you want to place the part, you can select the plane. It depends, you will know it later on. Normally they select YZ plane as the 2D plane. Select it, it presents as SketchUp plane. I told you 100 mm length. Click here, 100 mm. And this length you don't know. Here what we do is in Catia, you select, this is a drawing shortcut with line. This is ellipse. This is spline. This is circle. This is rectangular. This is different shape. Okay. This is point. This is axis. And point itself, there are so many things like this. And line, it can be line like this, infinite line. It may be tangent. It may be bisecting line. It may be line normal to the curve. Okay. And here, it is spline, connect spline, unconnect spline, and circle. Here various types of drawing: circle, complete circle, 3-point circle, and circle using coordinate system, circle using lines, tangent lines, arc. This is an arc. This is an arc with 3 point. This is an arc with 3 point. This is a 3-point arc. This is also 3-point arc starting with limits, and this is the arc with the center. So this is how we can draw arc and circle from this tool menu. This tool menu, arc and center. Rectangle. Here you see. Here you have rectangle. You can draw. You can draw oriental rectangle, any different shape. This is parallelogram. You can draw, and you can draw elongated hole. That is for a keyway and other things. This is elongated hole, circular elongated hole. You can draw. You can draw Q hole with a profile. You can draw hexagon. You can draw center rectangle. You can draw centered parallelogram. And here you can draw any profile you want. You can draw the profile. Now our job now is to draw a rectangular bar. So rectangular length, I'm keeping 100. What we have to do, click on the line, click here, and simply draw any line of any size. So now select this constraint. Click on constraint. Select this. Assign a value. This is 100. Or the other way we can draw is just draw a line. Click on this. The screen will appear. It is already first coordinate is there fixed 0, 0. This is from starter to the center. Second one horizontally it should be how much? It should be 100. We can keep vertically it has to be 0 and let it be 0. This is how it can be. And then we can, this is called horizontal constraint. We'll discuss this later on. As we proceed, we will know about all these things. Now we want to apply a constraint. If I apply constraint, the line will not get changed. We do not apply it to be changed. And here the constraint is applied 100 mm. So if you click on this, you can say 200 if you want to change the sign, or let it be 100. If you do not apply the constraint, what is going to happen? I will tell you. Then you want to change the line, you have to click on this, and you just change it here. Like this. Okay. If you apply a constraint here, like this. One line is strong. Now, rectangle, see, if you imagine a rectangular bar with its section is rectangle 100 by 50. So, what we have to do is, first we draw 100 by 50. This is once again, this is, we draw it 50. Click on this line, this, click on this, join. This is automatically constraint. We need not apply constraint because horizontal, vertical. This is horizontal constraint, the vertical constraint. That means this line will remain horizontal all the time. It will not change. And this line will always remain vertical. So the 90 degrees always maintained. And this is 15, this is 15. Automatically this line will be constrained with this horizontal and this will be vertical. So there is no necessity. And this is circularity. That is, this is called, is always connected with this. This is its meaning. See, this means coincidence. This point is always coincident with this. It cannot change position. Okay? So this is all. So you have to ensure that this is a closed figure. See, this is a closed figure. You have to ensure that all the lines are coincident. These are all connected together. Okay? And then you click on the exit workbench. Exit workbench. So it looks like this. Okay? So looks like this is a closed figure. It looks as if we have drawn from wider plane is at an angle. Now this is highlighted. If I don't highlight, the highlighted we referred here, no optional. I will show you once again what is that. This is selected element. When you select, it color become like this. Select, see, select color become like this. Select color become that way. So that we have set it. So, suppose you want to different color, you can always make it change. Want like this, the color is changed. Okay. So I don't want that color. I am familiar with the orange, so I will select orange color. Okay. Highlight. Now this is a rectangle, and there is a command called extrusion. So extrusion means you know that it will be the bar will be elongated, its cross section remains the same. So here is a shortcut menu. This is called pad. Pad means it is extrusion. Pad is a command for extrusion. You can also select from some of these here. You can select here, or you can select here. Anywhere you can select. Or there is also one customize list is there. Just a minute, let me show you. Not this. Command properties you can also select from another list. So we are going to select this, select shortcut pad. Okay, there is green which appears here. Initial default value is 20. It is in which direction? It is towards zoom outside or zoom inside. The two directions are this way or opposite to this. See, the arrow mark shows it is away from the screen. The opposite to this is towards the screen. Which direction you want to extrude it or increase the length? I want to increase the length, say about 500 mm. What you can do, enter 500. It is increased. So here you have pad. This pad will have some properties. Click on this, the same properties. The pad is, that is the extrusion is made from this Catia L1, that rectangle sketch we draw. And if you want to reverse the direction, click on this, it is reversed. Okay, reverse direction and keep it like this. So, suppose you want to make it hollow. What we have to do is click higher. Here, suppose you want to have extension on both sides. Click here. I will tell you how to do it hollow later on. First, suppose I extend the opposite side from the center line also. It is extended. Okay. Similarly, suppose we want to reduce the length. 400 only we want, and then we have to. It is reduced. That is away from the center line. It is 400. That means the extrusion is from center line. It is 500, and then it is reduced by 100 from the center line, and it is offset from the center line. So you click on this. This is, and now this is the 3D model. This you can visualize. This is actually, it is rendered also. See here, this is the red line. This is rendered like this. The lines will be black. I have shown you there. Lines will be black. Edges will be black. Suppose we don't want to show the edges, we can click here. Don't show the edges, and click on this. It's only hidden lines will be shown. You don't want to show the hidden lines. You click on this and click on this. Edges will be shown once again. Click on this. It is a line shading only. The outline is shown here, rectangle. So rendering, it is rendered. Without any edge line, rendered doesn't make much difference. For time being, you know about it. This is what close. And now this is the isometric view. This is called isometric. Here it is isometric view. It is, now we want to change it to front view. This is, see here, this is front view. This is called front view. It is front. But it is on the same plane. It is not the SketchUp plane. It is in the 3D plane model. It shows the front view. Click here once again, isometric. Want to side view, back view, you can click here, that's shown black. Once again show you how it is. You just visualize how it changes its position, back side view. Okay? And you want to show the side view, click here, shows the side view. So like this we can see the different views, the drawing. Okay. So, and this is, we have learned about a simple drawing, extrusion drawing, and this I will end the class now and we will deal next time.